Hello guys, good evening. Welcome to the session. Today we will talk about Databricks and how relational entities are managed in Databricks. Let me briefly introduce about this Databricks. This Databricks is a platform. It's like a cloud platform. Basically, it's used to read and write your data. In between, you can transform your data. And it's not just read and write. Here you can build your data warehouse. You can build your data lake. And Databricks is based upon a concept called Delta Lake. Actually, it is can be referred as data lake house. You can read data from different entities into the Databricks platform. If you want to save your data as it is in its raw format, in file format, you can do that. Files you can save. And you can also arrange your data into rows and columns like a data warehouse. That's why it's called as data lake house. And we refer these tables as delta tables. Not read. You write from different data sources, collect and write here. And you can perform different kinds of transformations, transform your data. It could be ETL transform or machine learning, artificial intelligence. All of these things are supported by Databricks using its computation platform where you can run PySpark code, Python code, Scala code, SQL code. So using any of these language, you can read your data. You can, of course, pre-process your data, transform your data, and you can read your data. Read data to different BI tools or ML2 algorithms and so on. You can make use of your data for analysis. That's what Databricks allows you to do. It manages the platform where you can effectively work on your data. You can store and there itself you can transform, and it supports different various forms of saving your data. That is Databricks. Today we will talk the relational entities, how they are managed in Databricks. Before that, first we should understand the Delta Lake concept of the Databricks. See, in this Delta Lake concept, what happens? There will be data catalog and there will be meta store. Okay, this data catalog is a place where data is physically stored in its physical form, and meta store is the place where metadata of the data is stored. Suppose a CSV file is coming. That CSV file will be converted into Parquet format. Suppose if you want to write it into the table, it will be available in the data catalog. And if you want to read the file from the data catalog, you have to run its file system commands. And this data catalog with the help of Metastore will create tables. What is metadata? How many columns are there? What are the column data types? And what is the table name? And what is the source of the table? What is the format of the table? In short, what is the column names and data types together we call schema. What is the schema of the table? All the things will be there in Metastore. Now, with the help of these metastore details, Databricks was able to show you the data in the form of tables. And that's how it operates its lakehouse architecture. That means data is available both in the format of files, flat files, and also as a table, right? And it has a file system, it has a metadata store. And to bring in data into tables, we have to first create a data warehouse. These data warehouse will be having databases, schemas, tables. It is nothing but a logical hierarchy you are mentioning, how you want to arrange your data in different schemas, different containers. Right? If you're creating two databases, means you're creating two containers. In two containers, in whatever container you want, you can create your table. So different data, you'll use different databases and you will place in different tables. That's how you organize your data. And to organize your data into tables, you need to create something called database and schema. By default, there will be Hive data warehouse. This Hive is responsible for saving all the metadata storage. So that is in short how Databricks was built and how it was able to manage both file system as well as tables case. Now let us look into more details on how it handles relational entities, meaning we are concerned and we are going to talk about this part, structured part of Databricks. Tables, databases, schemas. Okay. Relational entities. What are relational entities? Databases, right? You'll create a database, which is nothing but a logical container, right? In the database, you will create table, which is actually organizing your data into rows and columns. And from here, if you want to share physical table, you will share it. Suppose if you want to create a temporary view of your table in the memory, you will create view. This is a temporary form of table that stays in memory only, views. And these are the relational entities, not only here in any data storage. If you take data warehouses or if you take databases, this is the hierarchy on how the entities are arranged. Now let us look into those things of Databricks, these relational entities. First, we should talk about the default database. Already there will be a database with the name default in the Hive metastore. So just now we discussed, guys, how Databricks is managing both file system and also the database because of its Delta Lake, right? It is saving both the files in the form of Parquet. Of course, you can also save your data in CSV, JSON, text also in the file system. Suppose if you want to load your CSV file into table, first your CSV file will be converted into Parquet file, and these Parquet file and the details of the Parquet file will be there in the metastore. And this file system along with metastore support, which is Hive, will show your data in table. So by default, you have a metastore called Hive metastore, or rather it might call it as a data catalog, because Databricks keep on evolving. Initially, they used to display this name Hive Metaster. Now they might call it as something called data catalog. You have a default data catalog here. Using that, you can create your tables in some space called default database. Right? You can see the Hive Metastore already has this workspace. It's nothing but a workspace. You can directly create tables here. And in the underlying storage, which is file system, your tables will be saved. So that is one way you can create tables. No, for some reason you don't want to go with default database, you can create your own schema. Then you can create your own databases and tables within them. If you see on the screen, you don't want to go with this default workspace of Databricks data catalog. Then you can say create schema. I'm saying create schema dbx. It creates another space. What is this? It's nothing but a logical container. So within that schema, I can create my tables. And within this schema, I can also create databases and tables. So both ways can do. Schema is nothing but database, right? A separate section of database. Okay. Now, if you look into the storage, what happens? When you create a schema, a separate folder kind of a thing will be created in the underlying storage. We are calling this as file system, right? You can assume this file system as your local file system. In your local file system, how will you separate your data by placing in different folders? The same thing, already one default folder is available for you. There you can write your tables. Now, if you want your personalized or customized space, then you can go and create a new space. What happens in the file system? It creates a new folder and you can create tables within them. Right? That is what we call create a schema, custom schema. You're customizing the schema. And next we will talk about database, how you create database in these locations, custom locations. See, this is your default storage. This is the custom path which you have created just now. And this is how you will create. Sorry, guys. See, default database is there. And when you say you created schema dbx, within the same local Hive store, using, you got dbx. Now I want to customize this a bit more. So I am saying that I want to choose the location also. So it is assigning you some location. There is a main folder for it, which is Hive. Your username and Hive is there. There is a main folder. No, I don't want to maintain the same folder for both the workspaces. Then you can say custom location. You will define your own custom path. In that custom path, you can create your database and tables. That is one option you have. We will explore all these in more detail in the hands-on, guys. And then creating external table and creating a table in default database. These are things that are we need to discuss. See, when you create table, and if you are creating it in default workspace, that is database, your table, you are not mentioning anything, you're just creating a table. Your table is called as managed table, right? And suppose if you are creating your table in this path, which is not from your default database, it is called external table. Outside the directory in a different location, it is called external table. This is called managed table. We will discuss what is the difference between managed table and external table. As of now, I want you to remember, when you are creating your tables without mentioning anything in your default database, they are called managed tables. You can create your DBFS separately, and you can create tables there, and it's external table. See why this external path is given in Databricks, this facility, because Databricks supports external storage also. This storage is internal to the Databricks. Within this storage, if you want a separate partition for you, you can create by saying location. I want to create table 3 in the location, and you give the path within your database file system. Some folder name, that's it. You will mention the path. Their table will be created. And you can also bring in AWS S3, Azure Blob Storage, Google Cloud Storage as your external locations. Right on top of it, you can create tables. So that's why I want you to understand this concept, external table and managed table. Managed table will always be within the DBFS. When you want to create a table from these kind of storages, you have to create it as an external table. And within the Databricks file system also, you can create your managed tables, external tables. Yep. Those are like a few terminologies, guys. And see, we are creating a table in DBX, which is in the same workspace, but not default database, but still it is in the same workspace, Hive. Now here, DBY is a separate workspace. It is from a different path. And this path can be the Databricks file system, or you can make it as Amazon S3, Google Cloud Storage, like this. You can choose these options. And here one more thing showing you're creating your table in DBY, which is like external. Right? This is, you can assume at this point of time that there is a storage which is like your laptop storage, and in laptop you will save your files. In the same way, in the Databricks file system also you can save your file. But the thing is, you have some default folder. You can save your files there. This is like a parent folder. Within that, you can directly write your files. No, if you don't want that, you create a subfolder and write your file, save your files there. No, I want some external hard disk. I'll connect that external hard disk. There I'll create a folder and I'll save the files. That is also you can do. Same thing with the Databricks also. Right, this hard disk, in place of that, you can replace the cloud storages. Right. Now, let us go to the hands-on part of these entities. Up to this point, clear, guys? Right. Now, the first table I'm going to create is the default table or managed table. I'll just run it. You can see I am using the catalog called Hive Metastore. And my table name is manage default. I'm just writing one line with a few attributes like country, code, and dial string. And these are the columns of my table. And I am just writing one row into it, France FR plus 33. Here it is just created in our default workspace called catalog, and that catalog is Hive Metastore. Here I am not creating anything. I am saying use catalog Hive Metastore. That is the default one. And I am creating table as is directly. I am not specifying any location, any schema, nothing. Now what I am creating is called as manage table case. Let us run this. Right, we created a table all with the default option. Table name is manage default, and you can see the number of rows 1, number of inserted rows 1. After creating table, I have inserted the data into it, a row into it. Now you can check out this thing called catalog. If you go there, see, because I have executed these commands earlier, that's why I have all these. Otherwise, you will be having only default database. That's what we are referring to. You will be not having custom and new default. These are created by me. You will be having only default database. In the default database, what I have done, I have created manage default. See, it's asking me to log in once again. Let's wait. Okay, right. Now you can check this in catalog, in default, manage default. Right, when I click this, it's taking me to the sign in page. So I'll just go back. So instead of just checking in the console, we can say describe extended manage default, which is nothing but table. I want details about this manage default table, and you can see there is a lot of metadata about it, and that's what we are discussing. There is a file system which saves data as file, and all other details of that file will be saved as metadata. And you can see the metadata, what are the columns available, column name, data type, and other details, where it is saved, database, which database, default database, table name, manage default, and created time. And among these metadata, I want you to notice this. I'm using catalog as Hive Metastore, the default underlying storage, Hive Metastore, which also saves your metadata. And the database is default. And there I created the table. Now here, I'll create an external default table, meaning my storage. Here you see location. It is DBFS user Hive warehouse. There I created my table. So I'm trying to make you understand that there are two components. One is the storage where your data is saved as files, and this is the location. And when you want to write your data into tables, so where let's go here. See, Hive Metastore is used. Catalog is Hive Metastore, and the location is this. Database is default. Okay. Now let us create external default, meaning I am creating an external table. Now what I created is called as manage table, the above one. So what makes the difference? Here I have just created the table, that's it. But here, while creating external table, this one guys, create external default, I am giving the location. Hey, I don't want your default location. The file system will be same, dbfs, but create in mnt, which is a folder like structure. There create a demo, and there create external default. I want this location. I don't want the some random location. And the same thing we are doing. We same table and same values we are writing into that table. I'll run it. Okay, same. Now I'll describe this table. You can see first where the files are stored in mount demo external default. But still the database is same. Catalog is Hive Metastore. And the table type is external. Table name is external default. So these things you want to observe. Type here. This is external table. And this is managed in this location. And but why it is called a default table? The underlying file system is a different one, but the database used is default database. We will quickly compare this with these things. You see here type is manage table, and table you can see manage default, and it uses database as default, and location also the default location. Now why it is important to understand manage tables, external tables, we will see. Now next thing what I'll do, I'll drop the table. I'll drop manage default table. Run it. With this thing, what happens? We have two components here. File system called DBFS, Databricks file system. And they have Hive Metastore. Of course, using this Hive Metastore, there are databases. And files from here, their metadata will be saved here. With that, tables will be showed to you using that metadata. Now, when you delete a managed table, this file will also get deleted, and the metadata in the metastore, which is needed to show the data as a table, that will also get deleted. So metadata is the thing which is showing the table. Since it's a managed table, your data will be permanently deleted. Now, if you don't want this, right, even though you wanted to delete your tables, but still you want that file, you only want to delete the metadata. For some reason, you don't want the table, but still you want the file to be there in the file system. Then you have to always create external table. For just testing purposes, for sandbox kind of environment, for demo purposes, managed tables are fine. But in production scenarios, it's always recommended to create external tables case. Now I drop the table and it is obvious when I try to get things from manage default table, it will give me an error. It is not there. Table or view not found. And one more thing I'm not only trying to get the data from the table, I'm also trying to get the data from underlying file system. Here, SQL is not required. One more thing in Databricks, you can choose your language. This notebook is capable of running R code, Scala code, SQL code, Python code, Markdown, all these. Now, I am not using any of this. I'm just asking, I'm just trying to read the data from the file system. So depending upon the type of language you are using, you have to mention here. Suppose you are using Python means %Python. You have to mention it. Now I am not using any language. Want to read data using a Linux-like command. So for that, you have to say %fs. See, want to list out the files that are there in user hive warehouse manage default, and nothing is there here. File not found. Both are not there. Table is not there. File is also not there. Now that is not the case with external tables. I'll drop external default. You can say this result is stored as SQL data frame, DF, and can be used in other Python cells. Okay, I have dropped the table, but still it's saying that it's not dropping it entirely. It's available at this location, _SQL DF, in the form of table. Apart from that, the file will also be there. Now %fs ls, see this is the location. We have given this location in Databricks. It's not the default location. I'll run this. You can see the path. Only the table is not there. And that too, the table is available in this path as a data frame. Just for your, you can use in your Python code as a data frame. It's not available as a physical table. And that physical table is not there, but the file is still available in this location as a Parquet file. That is the difference between managed table and external table. Now here, what we have done, we have used the same default database for both of them. But in managed table, it uses default space of DBFS file system. But for external table, we have created a new path in the DBFS, some external path, not external, different path, right? So that makes external table. That's about tables. Now I can also call like this. Even though I deleted the table, I'll say select everything from delta dot and your path. I'll run it. See, it gives you the value, even though table is not there. Because you have the data frame available, _SQLDF. See, when you drop the table, that's what it prompted to you. Your table is available in the form of data frame. So not only using Python, in SQL, using your SQL query also, you have to just say delta dot and the path of your file system. Now, if you want to remove, you don't want that data in the file system also, then you have to run this one, db utils. It is a library. In that you have to say fs.rm remove and the path. See, true. That means it is removed. Now, if you try to run this, it will not work. Right? Analysis path not found. Anyways, table we have already deleted. Table is also not there. File is also not there. Now, one more thing we have to discuss. I'll just go back to presentation now. See, we talked about default database, external, creating schemas in the default database, but separating the storage when you create a different schema. So schema, you see the location we have separated, not schema yet. Yeah, this thing we have discussed now. Using default and separating within the storage. And the custom path, you can give the custom path location. Next, we will look into creating schema, different schema. Let's see how it will work. If you see, when I create this thing saying use schema dbx, not only the storage, you will get your workspace, that is Hive Metastore also, you are creating a different one. That is the thing. So this is also a different one you are creating, not going with the default one. So what I'm doing, I'm creating a schema called new default. I'll run it. It says that new default schema is already there. So let's say new schema default. I'll just take this underscore and run it up once again. See, new default schema was created. Now I want to check out the details. What happened underlying when I do this, when I create a schema, what is happening in the underlying file system of the Databricks? For that, you say describe database extended new default. That is the syntax. And run it. You see what is happening. The catalog name is still Hive Metastore, but we got a new namespace called new default. And location, we are going with this location. Location also new one. So both the thing is new one. Right, and we will create a database. Now see, I'm saying use database new default. There I'll create a manage table and I'll create an external table. Run it. See, this is same stack we are creating. Manage table means if you delete everything, if you create, if you delete the table, you will see everything will get deleted, both the file and table. External table means even though you delete the table, file will be there. And these operations, where are you doing? Not in the default metastore. Now you are creating your own metastore. So when you create your own metastore, new default, see already this Hive metastore is there. It is providing everything, the environment for you. There will be some default metastore. and the dbfs will be there. There will be the default dbfs. When you don't want to mention customize anything, you can use these two. You can stay in default meta store, but you can create a different location. We have seen that. Now what are we doing? We are creating a new default in the same Hive meta store. A different space will be given to you, and here with this different space you will also create a different location automatically. When you're creating a different workspace, it will not be sourced from this workspace. It will be a different workspace. And there, when you say manage table, you are not mentioning any, you're not separating your storage. So just like the manage table we have seen earlier. And external table, here you can create a separate folder of your own. So that is external table. Now let us run this. Already done that. Analysis exception, already run that. And we have inserted one row in these two tables. And I want you to observe the details. These details, among these all metadata, table is managed table. Type, you see the managed one. And if you see the location, see there is a new default.db. And this came because you created a new schema. It's saying that it's a new database, different workspace. You are getting a different workspace. That's it. Right, I'm dropping these two. And see, I'm trying to locate managed table first. Obviously, it is not, it won't be there. Sorry, managed new default, and there is external new default. Two things. And it's still showing the path. And for external new default, let us run it. See, here you have delta log. There is one snappy.parquet, and still you can restore your data. But here, if you see, there are two Parquet files. So this showed you the file, but it will not be available because it's managed table. But here it is available. Still you have it in your file system. Now you can also customize your locations. It says this already exists. New custom location. Run it. Right here, what we have done, we have just created, use the same space, workspace. Let's go back. Same workspace, Hive Metastore. Within the Hive Metastore, now if you want to customize your location, yes, that's what we are doing. We have a folder called shared. There you can create schemas and your own custom DB. It's nothing but the same space, guys, but you are customizing it. So we got customized the space, workspace, and this give you the details of that space. Catalog name is Hive Metastore only. The environment will be the same, but the namespace, you see the custom, it's not default one. And the location, it's created custom .db. And the same thing we are doing, we are creating the database, managed custom, external custom, and inserting data into both of the tables. So now what we are trying to understand, the different ways of creating databases and tables in data catalog or Databricks. So it's just an attempt to make you understand that there is DBFS, there is Hive Metastore. These will be same. If you want to customize these environments, you can customize. You can create your own workspace here. See, I have created custom.db. So that will be created here. I have created some new default.db that will be created here. When I create a different location like this, so by default, there will be a folder called default. Now, by providing a different location, you are creating a different folder called MNT. In that MNT, there will be demo. And there you are saying you want to make use of this external location. So where this is helpful, suppose you are pulling data from different sources, not from a single source, not from a single project, but you are using same environment. Let us say you are working with some e-commerce site. Yeah. They have given you a Databricks platform. And as a data engineer, you have to organize the data effectively. And you already know that there is a DBFS and there is the Hive Metastore. You are extracting customer data somewhere. So you will say that, hey, create a folder called customer. There, you will put so and so date according to the date or month. Those customer registration, you will create one folder with the name of date, and there you will save that file. Let us say this is CSV file. You extracted it from a customer database. Now in Hive Metastore, I don't want to go with the default workspace. So I'll create customer DB. That is my Hive's workspace. And there I'll create external table. I'll create external table. And this table name, I'll say this is Jan registrations, customer registrations. Like this, month-wise, you can create a table using this data. Now let us say log data is coming. Now log data, you are directly leaving in DBFS. You are loading into the DBFS. What is this click.log? Customer clicks. How many times, how many clicks, how users has clicked the products. It's a humongous data. So you saved in a clicks folder, right? Clicks.logs. You'll do some transformation, clean, you'll understand the pattern, and you'll transform it into Hive Metastore. But these are humongous data. You have splitted the data into chunks, part 1, part 2, part 3. And Databricks also provide you this platform where you can run PySpark, Python, SQL, all the languages. Let's say using PySpark libraries, you have splitted this data into parts based on their location or customer wise or time wise. Let's say by observing the time, you have divided this into parts. Now I want to load all of this data, right? Or I want only part 3 data. I can say this is clicks workspace, clicks.db. In the clicks.db, bring this table. But saving clicks as a tables forever is not a practical thing, because after a while we are not interested in clicks in a structured format. It is just log data. But customer data, always you want to store it as table only. So you'll just put it as a managed table. Once the analysis part is done, you'll just delete the managed table. So part 3 along with this will get deleted, or rather, sorry, not managed table, external table. We'll create an external table, you'll delete the table, but still file will be there. When you know the environment, you can organize things in better way. So that's why we are talking managed, external, custom spaces. Now here, what are we doing? We are creating a table in custom workspace, in custom metastore. And again in the custom metastore, we are creating external custom table and managed custom table. Run it. See what I'm saying? I'm saying use database custom. Whereas in the first cell, I'm saying use catalog hive metastore. That means you are choosing default one. Now you don't want to put everything into the default workspace. Okay, this one done. A new custom, we created it. Now I'll use that new custom here. Run it once again. It says that cannot create table new custom. I'm saying use database new custom. Is not empty. Okay, that's fine. Next, we will just, that means already I have created it. Once again, with the same names, I'm trying to write into it. That's why it's throwing an error. I'll just run this to describe managed custom. Saying that it cannot be found. Okay. I'll run this first. It is there. Environment called custom DB is there. Or I'll change this location, maybe using the same location as the problem here. Run it. See, now it took it. And here also I'll check for the details of it. Demo custom. See the catalog, the environment is Hive Meta Store, but the namespace is demo custom. And the location is the location which you have mentioned here. Okay, here also I would say this demo custom and run it. Right, and we are checking the table details, like where tables are stored, in which file system. This is a location, shared schemas, demo custom.db, and this is a table name. And you see the database, demo custom database. Is it managed location? True. Okay, those are the things, guys. Let me summarize. We understood how to create databases and tables in Databricks, like how you can create in default environment, how you can create them in your custom environment. Default environment comes with default file system, default Hive store. Whereas in custom, it's up to you. You can keep your metastore as default, but change the location. If you want, you can change both. You can go with the same default DBFS, change, sorry, other way around, right? The first thing we discussed. You can go with the different file location, same metastore, default metastore, right? Or you can change both. You can create a new location, new metastore, right? And these locations need not be your from database, Databricks file system. It can be from AWS S3, Azure, and Blob. How to do that, we will discuss in our upcoming sessions. Clear, guys, up to this point? And in each of these spaces, again, you can create two types of tables: managed table, external table. See, you don't care much about your data. It's like some third-party data. It's not very sensitive, very important. You can create managed tables. When you delete them, entire data will get deleted. You feel the data is important. You want to make your data tables fault tolerant against accident deletions and all. You can create external tables, either in your default or custom environments. These are the things we have discussed, guys. If you have any doubts, you can ask. Okay. Thank you, everyone. Bye-bye.